Okay, so I know we need more practice on this. I know there are people that are still confused on why am I sometimes putting a decimal, why am I sometimes not. We got to show the right degree of precision. That is our success criteria, is that not only can we make accurate measurements, but we got to go to the correct level of precision. So on the first one, I believe we said that was 24 is what we said. Okay, always put the units, 24 milliliters. Number 2 is kind of coming here just below 9. All right, so, or maybe some people put 9. If I thought it was just below 9, I would put 8. I put 8.3 yesterday. The problem was, if you look at yours, you probably should have disagreed because I made this line lower than what it actually is. When I looked at it without my line there, it looks like it's just under 9. But the main idea, like I said yesterday, is getting the correct number of decimal places. So we should know that in this measurement, since ones are my smallest mark, I should estimate one spot further. Another way to think about this is if you just kind of make a template each time. Maybe you make some marks like this for your number. And then you go, okay, so does it show all the tens places? Can I see 10, 20, 30? Okay, this only goes up to 20, but I can see 10 and 20. All right, so the tens place, I can see that on this piece of lab equipment. Can I see the ones place? Yeah, I can see 1, 2, 3, 4, 5, 6. I can see all those. Okay, can I see anything farther than that? And the answer is no. Okay, I cannot see the tens place, which means when I do my number, I should estimate one spot further than I can actually see on the measuring device. Okay. So that means this number should have one decimal place. So if I thought it was right under 9, I could put 8.9 milliliters. Maybe you thought it was 9. Maybe you think it's right at 9. But we can't just put 9. We got to show that there's one decimal place to show that we understand how to do this. Okay? So that would actually be 9.0 milliliters if you thought it was that. Maybe you put 9.1. Maybe you put 8.8, 8.7, 8.6. Yesterday I put 8.3. All of those are acceptable because what I'm going to do when I look at this is say, does the measurement make sense? Like obviously I wouldn't accept like 4.2. That would be way off. All right? But I go, does it make sense? Is it fairly accurate? Cool. Did they use the right number of places? Did they go to the tens place? Okay. So on number 3, what we've got here is, let's check the places. I can see the tens. Okay, so here's my spots for my number. I can see the tens. I can see the ones. Anything lower than that? No. So we're going to have one decimal place in this measurement as well. Did you guys think it went right to 40? If you did, it'd be 40.0 milliliters. Maybe you put 39.9, maybe you put 39.8, maybe 40.1, but somewhere in that general vicinity with one decimal place. On number 4, looks like ones are our lowest spot again, so I'm going to go to same thing as this for number 4. So I would call that, maybe it's right at 20. That would be 20.0 milliliters. Pizza cake. Okay. Number 5. So number 5, make the little template here. Can I see the tens place? Yes. Can I see all the ones? I do have marks smaller than 10, but it looks like it's 2, 4, 6, 8, 10. So it's every 2. So I do not have every one marked. So I'm going to estimate that spot. So this is only going to go to the ones place. So if I look at this, here's 10, here's 12, here's 14. The lowest point of this, if you thought it was right at 14, cool. I think it's a little below. I might say 13 milliliters. No decimal places that time. Yes, good question. So yeah, if it's right at it, to show that you understand the correct level of precision, as opposed to writing for like number 4, just writing 20. So on the quiz you write, looks like 20 to me, so you write just 20. That's wrong. Because you've got to show that with this measuring device on number 4 here, you got to show that you know that ones are the lowest place that we can actually see and understand that we estimate one spot further. So you would want to put the 0.0, and I would go, yep, Avion understood the lesson. Cool. All right. So number 6, we've got, I can see the tens. I can even see the ones. So this time I'm going to estimate to the 10th spot again, like I did on numbers 3 and 4 and 2. So what do you guys put for that? What do you think it is? Maybe it looks like it's right at 16 or maybe a little lower. So maybe I got to have one decimal place though again, okay? So I can see the tens, I can see the ones, I can't see anything further, so estimate one spot further. So I should have to the tens place. All right, so maybe you think it's right at 16, you'd put 16.0. Maybe you think it's just below it, 15.9. Either of those answers are acceptable. 16.1, 15.8, any of those are acceptable. All right, number 7. So I can see the tens, I can see the ones. Again, go to one decimal place. Looks like it's right at 20 to me. So somewhere around 20, and we should have one decimal place in our measurement. And number 8, again, I can see the tens, but I can see 2, 4, 6, 8, but I can't see 1, 3, 5, 7, or 9. So I'm going to estimate to the ones place. To me, that looks like it's right about at 48. No decimal place on that number because I don't have all the ones places shown. Does that make sense? Okay. And then 9 and 10 were non-existent. So there's our answers to that part. What happened? These? Oh, there is. Oh, I got confused. I told students to skip that yesterday. Maybe they just answered that there. Which object had the greatest volume? Which object had the least volume? Good work. All right, so this is that method called displacement we talked about yesterday. If we've got irregularly shaped objects that we want to find the volume of, so displacement, when we've got these irregularly shaped objects, we can't just measure sides. We can't just, they're not liquid, so we can't just put them in a graduated cylinder. I mean, we kind of can with this method here. So if I look at these, I got to first look at my container as it is with just water in it, okay? So first of all, we should make the correct measurement too. So on this, I can see the tens, I can even see the ones. So when I write a measurement here, I should have one decimal place on this measurement. Looks to me like it's right at 17, so I'm going to say the volume here is 17.0 milliliters, all right? So then we take a battery and we put the battery in, and so now it goes up past 21, maybe almost to 22, maybe you said 22. Okay, I would say maybe it's just under 22, maybe 21.9. Okay, but maybe you said 22.0, whatever. So if I take away the volume of the water before, the difference between those two should be the volume of the object that's in there. So if the water level went up 4.9 milliliters, then that would be the volume of the battery. All right. Put a nail in. Looks like it goes up to let's say it goes right up to 18. Okay, 18 milliliters. We started at 17 when it was empty, so that's a difference of a milliliter. So volume of the nail, 1 milliliter. Okay, so it was at 17. I put a button in, and it goes here. Let's call that 18.8. Why not? So I might have slightly different numbers than you. Again, that's okay. Did you put 0.9? That's fine. You're correct. Oh, did you? Okay, so we're going to have differences in there because this number is an estimate. My estimate might be different than yours. Okay? That doesn't mean you're wrong. All right. And then, so 17 milliliters with no object in it. Put an object in, and it goes, looks like right at 20. So 20.0. It was at 17.0. That's a difference of 3.0 milliliters. So it would have a volume of 3.0 milliliters. So number 9, which object had the greatest volume? That would be the battery. And number 10, which object had the least volume? That would be the nail. All right. Record the volume of each object. We did. So that's how we do displacement. So Friday we'll see basically this worksheet. You'll see it again, not as long. Just take a few of these, take a picture of them, crop them, put them into your quiz. That's what I'll do. Copy and paste. All right. So other side. So that's what we do when we have irregular solids. Other side, we have regular solids. Nice. Piece of cake. So when we have nice sides that we can measure and multiply, like these rectangular prisms they call, or regular solids I called it, you just multiply the 3 sides together. So you guys have your calculators ready to help me? What's 4 times 6 times 8? Okay, what is it? 192, thank you. Now it says these units are in centimeters, so really it's 4 centimeters times 6 centimeters times 8 centimeters, which gives us units that are centimeters cubed, cubic centimeters. So 192 cms cubed. All right, what is 4 centimeters times 6 centimeters times 2 centimeters? That's going to be 48, isn't it? So 48 centimeters cubed. All right. Okay, what's number 3? 3 times 9 times 4? 108. 8 times 9 times 4? So all we're doing is length times width times height. That equals the volume of these regularly shaped solids, rectangular prisms. What's the length? What's the width? What's the height? Doesn't even matter. Just make sure you're multiplying 3 different sides. Okay, number 5, 4 times 3 is 12, times 2 would be 24. Number 6, 3 times 3 is 9, times 2 is 18. All right. And 7, I'm just going to write these next to them so I can see the pictures. 6 times 8 is 48, times 9 is 841. Just kidding, I made that up. What is the answer there? 7. 6 times 8 times 9? 432. 432 cubic centimeters. 8 times 3 times 6? 144. 8 times 5 times 4? 160. 8 times 9 times 3? 216. Okay, so that's how that's how we do that stuff. Cool. So today we're starting the lab, and we are going to be doing volume measurements. But we're also going to have to use not just graduated cylinders, we're also going to have to use rulers. We're going to be measuring liquid volumes. we're going to be measuring liquid volumes, but we're going to use regularly shaped objects so we can multiply the three sides. So let me tell you, on our rulers, this is going to look really bad, my apologies, but I just want to show you. Let's say this is the edge of the ruler. Let's say this is the ruler, all right? So I have my marks that I'm going to use. We're going to use centimeters. All right, so there should be, these are the smaller marks that you see, not the inches. It's not going to be the side that has 12 inches, it's the other side. And then there's going to be maybe a little mark in the middle, which is like a half a centimeter. And then you have these little marks here. Okay. So if this right here is a centimeter, okay, so I can see each centimeter, and we also have smaller marks. What those smaller marks represent is a tenth of a centimeter. Okay, so I can see the centimeters. I can also see these smaller marks in between. All right, so I can also see tenths of a centimeter. And then if I follow my rules of measurement, so we can see the ones, we can see each centimeter, we can see the tenths of centimeters, we are going to estimate that second decimal. So that means when we're finding the volume by using a ruler, we're going to record each side's length or width or height to 2 decimal places. Okay?